welcome the next speaker, Arnaldo Batista from Portugal. And we will hear about Braxton-Hicks waves in the electrohysterogram input for pregnancy monitoring.
Say 15, that's fine. He knows. They have 15. It's just very packed session, so I can tell you from now. Yeah, but it's gonna. So we're almost 10 minutes now. I think because he will overrun. No, 50. He can have 50. I promise you. Yes. He can have 50. Please, to make him happy. Yeah. It's fine. It's some miscommunication, I guess. I don't know. That's what breaks are so big for.
Okay. Good afternoon. First one, let me introduce you. We are a group of 4 institutions, as you see there. Nova University of Lisbon. And Innova is associated to the university, is a private research institute. And also you have the Nova Medical School in Lisbon and the Faculty of Sciences. So we are engineers, obstetrics, and mathematicians. Myself, I am an electrical engineer. I'm with the Department of Electrical Engineering and Computers of Nova School of Science and Technology. So my presentation will be about Alvarez and Braxton-Hicks waves in the electrohysterogram. So it will be all about the electrohysterogram. So I'm not going to talk much about uterine electrophysiology, just that uterine contractions are triggered by electrical activity in the myometrium. And I'm sure you know all these mechanisms, cell mechanisms about variations of permeability, calcium and potassium and chloride. So these are the various acquisitions, electron locations for the acquisition of the EHG. I'm sure the NEMO staff knows about this a lot. The 2 data sets that are publicly available are I don't seem to work with this. Pointer. Okay. Are the Icelandic database and the Fellsource database. They are the only ones that are publicly available. We are building our own database in Lisbon, and Sarah is our biomedical engineering student. Thank you very much. Thank you. That is doing it now. So there is not a consensus about what is the best electrode geometry. It is research now. We are using our own data, our own geometry, but we don't want to disclose it as yet because it's not protected. And we have several channels of EEG data where the contractions are automatically detected. They are the black traces, forgot about the blue ones. So basically the raw ECG is on the top. And the second plot is the ECG that is processed. If you make a zoom on the EHG, and if you make a zoom on the EHG, you have lots of artifacts there. Of course, depends on the application. But you have, for instance, here is the maternal ECG, but the fetal ECG should be there as well. So the EHG signal is something like this. The bursts of energy are correspondent to contractions. Alvarez waves are here in they might not be visible, but Alvarez waves and Braxton-Hicks contractions are inside in this signal. Alvarez waves are often at the level of basal activities. They are not quite visible. but we can detect them. So we detect them using energy bursts, but also using, you have to use another methods because the amplitude is very low. So we have an example here of our system detecting where's the pointer, please? Oh, yeah. Okay, very good. Okay, this is an Alvarez wave that has been detected, and this is an Alvarez wave that the system didn't detect because the amplitude is very low. And this is another Alvarez wave, and there is a Braxton-Hicks, and these are undetected Alvarez waves. So let me now speak a bit about the Alvarez wave. What are Alvarez waves and why are they important? We developed an Alvarez wave detector based on their spectral characteristics because the amplitude is very low, not their energy level. The method is called window slide validate and jump, and is working now. So in the EHG, as in the topogram, there are several wave types. The Alvarez is one of them, was introduced by Alvarez, that was an American doctor in the 50s. Then Braxton-Hicks, a British doctor, in 1872 it identified the so-called Braxton-Hicks waves. And also recently the French group identified the LDBF, that are the initials for the French designation. And also the Lemon waves that are rare events. So we were our work is about to detect this, at least of the Braxton-Hicks and the Alvarez in the EHG, because they are Alvarez have a potential to predict preterm. So that was our motivation. We're looking in preterm prediction. So these are the signal for contraction monitoring. You have the topogram, the EHG, and also the intermuscular manometer that I think is not used anymore. I may be wrong about this. But the EHG is the method that allows for earlier monitoring. It's not invasive. And it doesn't suffer of the problems that the topo does. That is inaccurate for high BMI subjects and a degraded predictive value. So what our technique was to get the waves, to detect the waves using their spectral signature, because these are Alvarez wave and this is a Braxton-Hicks wave, and they have quite different spectrum. So we focus on the spectrum, not in the time series itself. So our concern, our input, at least is wishful thinking, is about preterm labor. So it's a problem, as you all know. Preterm labor is one of the most relevant obstetric conditions. 1 in 10 babies is preterm, 15 million babies a year, lots of mortality and morbidity as well, like cerebral palsy, breathing and hearing problems and so forth. So the question is here, can Alvarez waves be predictors of labor preterm or not? Because the idea is that maybe Alvarez can also be predictors of labor, normal labor, and that would be important. This is the question that has been lingering around for quite a while, but nobody has a definite reply to it. But mind you that Alvarez itself, in the 50s, he stated that those components were predictors of preterm. But really he didn't prove it. So we did, our exclusion criteria was multi-pregnancies, fetal abnormalities, placental abnormalities, hydramnios or illogohydramnios, labor, and gestational age below 22 weeks. So we looked we made a bibliographic survey, and we found 12 important papers that support a link between Alvarez waves and labor, preterm or not. 12, all of them use the TOCO, not the EHG. And we found 3 main papers that they don't report, or they report a weak link between Alvarez waves and labor. So the majority support there is a link. And our quest is to explore Alvarez waves not in the TOCO, because it's barely seen in the TOCO, it's a very low amplitude, but in the EHG. So it has not been explored before, you are doing it now. We developed an application to automatically cluster, so unsupervising clustering of all the contractions, because we have to prove in the EHG what is Alvarez, what is Braxton-Hicks. So we use the energy for the contraction detection. We use the energy criteria. I mean, there is a burst of energy, you are going to get that. That is a contraction, at least for the Braxton-Hicks contractions. We did some tests. We found out that the squared RNS was the best method. And in the Icelandic database, we found 3,000 something contractions. And in the EHG database, we found about 4,000. So this is our data pool for classification. You want to know what is Alvarez, what is Braxton-Hicks, at least 2 conditions. So you select a method, either parametric or non-parametric. We select the Welsh method, is quite used. We developed the application, and here it is the result, where we have the contractions automatically detected. The black portions of the signal, and the uterine basal activity is the red, but it's got information as well. So, for instance, these 2 contractions here, they look similar visually, but they have different spectrum. So we looked for the spectrum. For the unsupervised clustering, you had to select a cost function. We dwelled through several hypotheses, and we found that Jeffrey is the best one for this task. And we got these interesting results. We finally were able to characterize the Braxton-Hicks and the Alvarez. Braxton-Hicks is this one, so it is a low frequency component. And also we found out that there are 2 Alvarez types. What we call Alvarez low, because there is a low energy here about 0.2 Hertz, and Alvarez high with a higher energy content. So we're very happy with this. You use to discriminate, you use the accumulative probability, so we could be sure that this is Alvarez and these are Braxton-Hicks. And when we plotted the Alvarez high and low against the time to delivery, so this 0 is the delivery time. It's not a delivery day, because this database only has 2 cases which we eliminated. We want it on 2 days before delivery, the maximum. So we are not speaking about labor here. This is not labor. So there is a surprising result. The Alvarez waves are not increasing. We would expect that the contraction would increase towards labor, but they have a peak somewhere here, and then they decrease. We have found this result before. It was quite surprising for our doctors. And also with Alvarez low, it is more or less the same. You have a peak about 4 weeks to delivery, and then it decreases. We still don't know why is this. So to really make a research on this, we have to have EHD databases, as been mentioned here. So we are building our own database. We still have several years ahead to get the number, the necessary number of preterm cases. So this is one woman that comes several times to be recorded, and you have several women. Then you have the raw data set, pre-processing and filtering, contraction detection and clustering. So it's going to automatically separate what is Alvarez, what is Braxton-Hicks. Then you have the database, and then you can work on this. Of course, the 2 databases, they are very limited in terms of preterm cases. You are trying to to correct that. And we have built our own way to show how the contractions could help about doing preterm prediction. We call it the contractiogram. So this here is the vertical axis. This is one woman only that was registered 7 times. So they came 7 times to hospital. The first time was about 3 weeks of gestation, the second 30, and the second was about 33 something, 39, and also the delivery date was 38.14 weeks. So each one of these points is a contraction, and each one of these vertical lines is a channel. We use 10 channels. So you can see all the contractions that these women had till delivery, and also the classification. The red ones are Braxton-Hicks that are more prevalent, and the blue ones are Alvarez low and high. You would expect that if Alvarez are predictors of term, you would have more blue here, but no, they are everywhere. So this is a problem regarding people that consider that Alvarez are predictors, but maybe you are looking at this wrongly. We have to do something like a contraction sequence. For instance, for the subject number 27, on the recording number 6 and the channel number 5, these were the contractions there. 12 Braxton-Hicks followed by 1 Alvarez low and 4 Braxton-Hicks. So you have this information, then you can apply AI models to this. It's like a DNA profiling, more or less. And we can hopefully predict term, labor, either term or preterm. This is what we see. So I'm finished with this. I just want to say that we have a Uterine Explorer platform where all the code is here. Our students, each one of these rectangle is a thesis. So our motto is the student goes, the code stays. And also this, it's my appreciation to my students. I'm here because they have other tasks now, like writing their dissertations. And this is our team. This is our doctor, gynecologist, 2 gynecologists. This is Sarah, biomedical engineering. We work hard on this. Thank you very much.
So thank you very much for this impressive talk, and thanks to you and this entire team that has been able to put this all together. One question I should know, but I don't. What is special about this database in Iceland?
Well, it's one of the most used databases for with the EEG. It just has the EHG and the topos. And throughout the EEG research is the most used data set. They have many citations, maybe thousands, because it's the most used data set. But it only has one preterm case, so it is a problem. It's normal, is mainly for normal algorithms for normal people, normal subjects. So it's lacking preterm.
And the external validation, has this been checked? Because
Sorry?
The external validation. The external validation.
Yes. We validate them before they put it online. They came to us. They knew that we had a Team Explorer, and they asked us to. They asked several universities, but they didn't tell us. So I learned later, and we validated it. It's very good, and it's public, so it's free.
Okay, great, thank you. Any other questions or comments? Well, if not, then I'd like to thank the speaker again and take the next one.